Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a cubic equation with complex numbers. In other words, we're going to be finding the cube roots of a complex number 18 plus 26i. If you're new to complex numbers, go ahead and check out my lecture videos. If you like algebra, number theory, and trigonometry problems, go ahead and check out CyberMath, my very first channel. Great, let's go ahead and get started. So we need to find a number whose cube is equal to 18 plus 26i, which means finding the cube root, but complex numbers have 3 cube roots. The only exception is 0. All other complex numbers have 3 distinct cube roots. So to be able to find the cube root of this complex number, we're going to go ahead and replace z with something. And what should that be, right? I'm going to use x plus yi, even though the name of this channel is A plus bi. For most problems, I use x plus yi. For actually locus problems, I use x plus yi. But anyways, for this one as well. So let's replace z with x plus yi. So when we cube x plus yi, it should equal 18 plus 26i. So we're going to go ahead and expand the left-hand side. How do you cube a sum? I usually use a formula, a cubed plus b cubed plus 3ab multiplied by a plus b. That's the formula I use. You can use the binomial theorem directly if you want, but that's what I get from here. I forgot to tell you, I squared is -1, or I can be considered the square root of -1. And of course, I cubed is just going to be I squared times I. Since I squared is -1, this is going to be -I. Just know powers of I, first, second, third, and fourth, and then you'll be fine. So here it's -I, which means x cubed minus 7y cubed I. And then if you distribute this, you're going to get 3x squared y multiplied by I. And we have the I squared scenario here, which is going to give us a minus sign, 3xy squared. And this should equal 18 plus 26i. So our goal is going to be to put together the real parts, put together the imaginary parts, and then set these two numbers equal to each other. And from there, solve for x and y. But that's going to be an interesting adventure. Okay, let's go ahead and put the real parts together. The real part is going to be x cubed minus 3xy squared, and then the imaginary part is going to be 3x squared y minus y cubed. Now, if you're familiar with the binomial theorem, in particular x plus y to the third power, then you'll probably realize that there are some similarities, but things are kind of jumbled a little bit here because of the I. Okay, we could also give you a problem like this as a system, which I'm planning to do later on, but that's mainly for another video. So let's go ahead and now compare the real parts. This is the real part, which is equal to 18, and this is the imaginary part, which is equal to 26. By the way, when I say imaginary part, that does not include I, it's just the coefficient of I. Okay? Let's make sure we get that right. Now from here, we get the following system. X cubed minus 3xy squared is equal to 18, and 3x squared y minus y cubed is equal to 26. And our goal is to solve for x and y, right? This is a cubic system, isn't it? How do you solve a cubic system like this? Well, first of all, I want you to notice that this is a homogeneous system, which means you can change the variable. In other words, the ratio of y to x is going to be, or x to y for the same reason, is going to be a constant. So we can just assume that in these cases, okay, suppose y over x is a. In this case, a is a constant, which implies that y can be written as ax. Of course, you don't want x to be 0, because if x is 0, then we don't get a solution. And y is 0 is not going to give you a solution either. So they have to be different from 0. Okay? Now let's go ahead and substitute into both of these equations y equals ax. And let's see what it does. Now replace y with ax, so that's going to give you a squared x squared equals 18. And then here it's 3x squared multiplied by y, which is ax, minus y cubed, which is a cubed x cubed. And that's equal to 26. Now let's go ahead and simplify this a little bit by factoring. X times x squared is x cubed, and x times x squared is x cubed. So this gives us x cubed minus 3a squared x cubed equals 18. And the bottom one is 3a x cubed minus a cubed x cubed equals 26. Now we're going to go ahead and factor out the x cubed now. X cubed times 1 minus 3a squared is equal to 18. And again, factor out x cubed. 3a minus a cubed is equal to 26. Now is a good time to divide these equations side by side. And then we can eliminate x cubed now. And guess what? We end up with a single variable. This is a cubic equation. And yes, we can solve it, right? If you go ahead and distribute, it's going to look like this. 26 times 1 minus 3a squared equals 18 times 3a minus a cubed. Negative a cubed, I wrote it on the right-hand side because it's negative. When we put everything on the left-hand side, everything will be positive. Let's go ahead and distribute and put it all together. We're going to get 18a cubed minus 78a squared minus 54a, 3 times 26 is 78 obviously, plus 26 is equal to 0. Now notice that everything is divisible by 2, so let's go ahead and divide. We get 9a cubed minus 39a squared minus 27a plus 13 is equal to 0. Now, this is a cubic equation which you need to solve, and obviously 13 unfortunately isn't divisible by 3, otherwise we could simplify further. But that's okay. This is a cubic equation and there's a formula for cubic equations, or you can just solve it directly. But the idea usually depends upon this term disappearing, so we don't want anything quadratic. You can change the variable and so on and so forth. Or if the solution is a good one, in which case it should be, hopefully, right? We expect to get rational solutions for A. So we can use the rational root theorem. So if there are any rational roots, we're going to be able to find them. And the way you find them is basically you look at factors of 13 and factors of 9, and you divide all possible factors by all possible factors, and all these possible ratios with the plus minus signs is going to give you the roots, if there are any rational roots, okay? And there are. And after some time, trial and error, so on and so forth, you're going to realize that yes, this can be factored as a equals 1/3 is a solution. And that basically comes from the fact that 1 is a factor of 13 and 3 is a factor of 9. So it works, right? It fits the pattern. But this is important. If a equals 1/3 is a solution, this means that 3a is equal to 1, or 3a minus 1 is equal to 0. In other words, 3a minus 1 is going to be one of the factors. Of course, once you know one of the factors, the other one is actually fairly easy to find. So in its factored form, our equation is going to look like this. 3a minus 1 multiplied by 3a squared minus 12a minus 13 is equal to 0. And like we said earlier, a is equal to 1/3 from here. The other solutions are not that good, but guess what? They still work. But we only need to find one square root, or one cube root, which I'm going to show you how to find the other ones. But a equals 1/3 gives us what? Of course, we also need to find b. And remember what we assumed, that we said that y is equal to ax, right? Y is ax. And from here we get, actually this is not like imply, from here we get y is equal to x over 3, or 1/3 times x. So now we're going to go back to one of our equations, maybe the first one, x cubed minus 3xy squared equal to 18. And from here, guess what? We're going to be able to plug in y and solve for x. X cubed minus 3x multiplied by 1/9 x squared is equal to 18. This is going to go into 9. And this is going to give us x cubed minus x cubed divided by 3 is equal to 18, which is 2x cubed equals 54, which means x cubed is equal to 27, which means x is equal to 3. Great, that's why we were able to find the solutions easily. And remember, y is 1/3 of x. If x is 3, then y is 1. And remember, we wrote our solution as x plus yi, so the answer would be 3 plus I. So, in other words, one of the cube roots of 18 plus 26i is 3 plus I. And to find the other ones, here's what we're going to use. We're going to be looking at the cube root of 1. So if you think about 1 to the power 1/3, and if you remember that this can be written as e to the power 2 pi n I, you're going to divide it by 3. Here, if you replace n with 0, you're going to get 1, so that's not very helpful. But if you replace n with 1, you're going to get e to the power 2 pi I over 3. And then if you replace n with 2, you get e to the power 4 pi I over 3. If I just take the first one, that gives me one of the cube roots of 1. Basically, this just means that if you write it like this, I times 2 pi over 3. By Euler's formula, thanks to him, he gave us beautiful formulas and beautiful equations. We can kind of write it like this. And if you remember, 2 pi over 3 is the same as 120. So cosine of 120 is going to be the opposite of cosine of 60, which is negative 1/2. And the other number is going to be positive root 3 over 2. So one of the cube roots of 1 is going to be this number. Some people even call it omega, and omega squared is going to be the other one, obviously. But guess what happens? If you take the solution 3 plus I and multiply it by w, when you cube this, w cubed is going to be 1 because this is one of the cube roots of 1. Therefore, you're going to get another solution. And if you multiply 3 plus I by w squared, then you'll get the third solution. Now, going back to one of our equations, if we use the quadratic to solve for values of a and use them with x, would it give us the same solutions? That's for you to check. Another thing that I want you to check before I leave you is, are you able to find the cube root of any complex number? In other words, there is a formula for finding square roots of a complex number, but the answer, the question is there a formula that allows us to find the cube root of a complex number like a plus bi? In other words, can you solve for a and b in terms of x and y? I mean, the other way around. Anyways, this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out Cybermath, the shorts channel. Yes, I have one. and aplusbi, and bye-bye.